Okay, I'm just gonna go ahead and start getting this started and make sure that everyone can hear me and all of the normal things, of course, because, it's been like a year since I've done this, so, tap tap is this thing on kind of situation here. Good, good. So I'm trying something slightly different with my text chat overlay and it's not C line at the moment. This is actually PyCharm. We'll talk about that in just a minute here. Excellent. Okay. Yeah, just let me know if you want me to change or resize anything. And since I'm just getting the introductions going here, I am going to be recording this also and hope to split it up into multiple episodes. So yes, you'll notice that I'm using Python here. So I'm going to record an intro that I'm going to use when I split up the episodes. So you get to hear me live say, "Hello and welcome to C++ Weekly. I am your host, Jason Turner. I'm a review to... Ha! That's when I always have to edit things. I am available for code reviews and on-site training." All right, in this episode, or in this series of episodes, I'm doing something that I'm going to call a little bit like C++ cross-training. And the idea is, well, you know what? We can't be good C++ programmers if we only program in C++. We need to do other things as well. And why not have some fun and do some game programming? But I've also been learning Python at the same time, so I have been prototyping this in Python. And my plan is that once I have what I consider to be a good prototype of the Python version of the code, we will then do a streamed port from Python to C++. Now that means that I am in fact programming Python in probably more of a C++ way. And in fact, I've gotten that comment recently from people on Twitter and YouTube comments and stuff that my recent experiments with Python have definitely been C++ style. And well, that just means it'll be easier for me to port things to C++ when I get there. Now, what I'm going to start with is the theory and background, and well, I'll show you where we are currently. I've shared some screenshots of this on Twitter, but I'm going to go ahead and hit the play button, and hopefully all of this works like it's supposed to with my streaming setup. But I have a very simple raycasting engine that is working in Python. And my raycasting engine at the moment is very simple in black and white because I intended it originally for use on the calculators that I've been talking about on the channel recently. But it turns out that it's actually pretty difficult to get the performance that you would need for something like this in a calculator with Python. So I kind of abandoned that, but right now it's black and white with textured walls. So I'm going to cover the theory for what we're doing. It's a little bit of a trippy camera. There is, in fact, fisheye going on, and we're going to fix the fisheye at some point today as well. But I also have very weird terrain, like you said. So let's go ahead and jump into that real quick as well. So my current map is, let's get down to it. This is the map. I have created this own tiny little embedded DSL, and each one of the characters represents a chunk of wall. And so if I have a forward slash, then it is this triangular shaped wall. Let's see if I can do this better. All right, so that's the triangular shaped wall. You know what? I did that terribly. I'm going to do it again. So those are the types of walls that I am capable of drawing. And then I go through and do a bunch of optimization passes and make it actually usable. But you can see then here that I just have this little embedded DSL kind of thing. And I'm able to, well, walk through that map now. We saw that I walked all the way around the outside edge of it and came in on the north side. Oh, interesting comment. Looks like a LiDAR point cloud. Oh, that's weird. I lost a bunch of viewers all at once. Now, I have absolutely no idea what the lag is. I did set this to ultra low latency, but I'm getting the impression that it is not ultra low latency right now based on your comment feedback rate. But, well, it's YouTube. We'll do what we can. Okay, I'm going to switch over to my camera. No, am I going to switch to my camera now? Yes, I'm going to switch to my camera. And I'm going to show the basic theory behind what I am drawing here. Cannot find previous videos. This is the first video. I am doing all of this right now. If you want to see the other video I'm talking about, it's just a video about it's just a video about Python on the calculator. So I can attempt to do a quick look at that. Ooh, I have an idea, actually. I do have an idea. Let's see if I can get this. There we go. So if you want to check out the repository as I'm going along, it is there. Lefticus/Raycasting. Now, since I have video of me turned off, you can't see that I'm taking drinks of my tea every now and then. Okay, I am going to switch over to camera mode. This is my camera. Presumably you can see it. Let's see, what is the delay? About 5 seconds. All right. I need a pen. Why, yes, I do have 2 ThinkPads on my desk. Why do you ask? Unfortunately, I've never convinced Lenovo to sponsor the channel. I'm just going to draw out a pretty simple room that I'm going to show you the general theory for how I'm actually doing this raycasting. And part of the fun here is that I have never actually done anything like this before, and really part of my intro should be the fact that I truly have no idea what I'm doing. I am not a game programmer, I am not a graphics programmer, but I'm having fun. So if we've got our camera, I'm going to put my camera right here, and my camera has a 45-degree viewing angle, although I notice that I've got terrible lighting on my paper. Let's see if I can fix that a little bit. Slightly better. Oh, that's weirdly harsh. Mr. Maintainer of all of the 3D graphics things, I already said I don't know what I'm doing. So that's not the point. All right. So I'm going to say that I've got a 45-degree viewing angle. And to draw that, I'm just going to draw straight across here. Seriously, if you want serious 3D graphics programming, please don't watch this channel. This is my eyeball. Can you tell? Okay, there's an eyeball right here. And what I need to do is figure out what walls I am drawing. Now, this is a raycasting engine. This is not real 3D. This is one of those like 2.5D raycasting things. Yeah, kind of like John Carmack did. Now, the idea is that to draw this, I am going to cast one ray out from the eye per pixel column that I want to draw. So this is going to be my display screen down here. And I'm going to say it's like a 3x2 kind of orientation. And I want to draw this wall in it somehow. And what I need to do is draw these rays out at some regularly spaced interval from my eye point. I've already gone astray. Oh, and I meant to change the title of this to say theory. I'm going to do that right now. Oh, no, wait, it's not displayed. Oh, well, it's fine. So what I do is I draw a line and I say, does this line intersect with any wall? And if it does, which wall and how far away did this thing hit the ray? Now I'm going to see how many lines did I just draw. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Good. All right, I should not have already boxed this in. That would be 20. Now, my goal is to actually graph out this thing on graph paper right here so we can see what we're doing. So unfortunately, this little inner box here is meaningless. But my first one, and yes, my ruler here is not spectacular, I hit a wall at 28 millimeters. So I'm going to log all of these up here. And the next one was 25. That's approximately 23. That is 22. That is 20. That's also, what is that, about 20-ish, and then 19. Okay. I really do hope this ends up making sense when I'm done. And then the next ray intersected a line segment at 71 millimeters. .72. So this is not going well. 71, 72. You all should be keeping track of this for me. It's also about 72. And then the next ray hits at 57. 54. 41. I really do hope this makes sense when I'm done. 35. 31. 29. 31. 33. 35. And 37-ish. Wow. Whew. Yeah. Oh, you know, hand-drawn ray casting. That's a thing. Okay, so now I know the distances. I know that from my eye, I see something at these distances. Now, as you get further away from the viewpoint, objects get smaller. So I'm going to draw a horizon line. Right here. And so I know my max wall height is 12. Now, if you stop and think about it, when you're like 1 millimeter away from something, how big does that wall look? Just go ahead right now and put your face 1 millimeter away from a wall and tell me how big that wall looks to you. Do you have any chance of estimating its height? Not really, right? If you get your eyeball right up against something, then once you're right up against the thing, that thing is practically infinitely tall. If you want to try my engine, I don't ask someone else to paste in the link. Actually, I can paste in the link. Oh no, you're referencing someone else, sorry. Yes, excellent. Yeah, you know, it's great to have fun writing raycasters. Hopefully, this actually makes sense. I see who's commenting there. I don't know what I'm doing. I only play a graphics programmer on YouTube, so please forgive me. Okay, so I've got 20 wall segments, or excuse me, 20 wall heights, if you will. So I know how far away each of these things are, and I know that the further away they are, the smaller they should be. So I need some sort of inverse scale relationship or something like that. And you know, how are these numbers going to play out? That's like something you just kind of have to tweak so that you give the depth of field that you want and the actual like ratios and everything that feel good. There's probably, you know, actual good math reasons to choose various options, but we just have to come up with something here. So if I say that the furthest away thing, the thing that's 72 millimeters away, is just 1 pixel tall, then I can do some sort of a scale from there to, let's say, 24 pixels tall, because I know my height is 12 total, but I also know if I'm right up against the wall, it needs to fill more than the entire viewpoint. So let's just say I want to scale from 1 to 24, and that would be, how do I want to do this? How do I want to do this? That's a great question. Now let's say the ones that are closest to us, we want to fill maybe 10. So I want 19 to be equal to 10 and 72 equal to 1. And then I need some sort of ratio. I need a calculator. Ironically, I didn't bring one down with me into my recording area, even though I currently own 3 really nice calculators. So maybe I should get a calculator. I'll be right back. While I get the calculator, one of you come up with what this actual ratio looks like. Need to remap 24 to 72 range to 0 to 1. Yeah, okay. Wait, why 24? 19? Well, which calculator should I use? Should I use the Casio? Or should I use the NumWorks? Just for the fun of it, we will go in here into the Casio while this is sitting here and execute the last version of this that I did actually have working on the calculator. Although, like I said, I gave up on that. But in a minute, we'll actually see it drawing a particular scene using this exact same logic. Yeah, working out the distance of wall height to distance, ratio of wall height to distance, that is. My brain is moving slow right now. It shouldn't be complicated. It's an inverse ratio, so yeah, see? There we go. That's the last version that actually draws a scene using this exact same logic on a Python calculator. That's the Casio running Python. Here's NumWorks that has Python. And here's the Texas Instruments with Python. So x minus 24 divided by 72 minus 24. That does sound approximately right. Excuse me. Yeah, we're going simple. It's just a simple ratio, y'all. Just the further away it is, the smaller it's gonna be. I'm not trying to be overly complicated. This calculator seems to have better contrast on the screen, though, on the camera. So if I say all right. So, as you said, obviously, if it's 72, then it's at 1. Oh no, it deleted my entire formula. What are you doing? What are you doing, calculator? What is happening right now? What in the world? Weird. All right. Yeah, I have a laptop over there. You you people just aren't fun. Fine. No, I'm gonna do it this way. We're going to map each one of these out. Wait, no, that can't be right. My brain is moving very slowly. Yeah. No, I wasn't trying to do 1.0 to, but that's the same difference. I'm, like I said at the beginning of this, I hope this all works out when it is done. That would be the normalization. What is happening? I am truly losing my mind right now. One moment, please. All right. So this is what I actually did in my actual game logic. I say the total height is 12, and I do the actual drawn wall height is equal to 12 times 0.75 divided by the distance. But my distances are going to be a different scale than these. Yeah, that's not going to working out. It's less than 0 and the wall is taller than the screen. That makes sense. I really needed to have more of a plan than this. Look at this. I'm losing viewers by the minute. I'm just reading your comments right now. Rethinking my life decisions, that kind of thing. The problem is the scale is not inverse, right? I am doing a paper model of the Raycaster and failing terribly because apparently I didn't come well enough prepared for this particular aspect. So I thank you all for joining me. Height of screen divided by length of ray. Yes, okay, right? That is approximately where I was getting. That's what I have here, height of screen times some multiplier divided by length of ray. Right. I'm just kind of, yeah, playing with the numbers here to get some kind of scale that seems to make sense. I know the overall height of my graph that I can graph is 12, and if I scale the distance relative to my overall height, which this is where my numbers accidentally kind of work out because I'm doing everything as 0 to 1 scale in my actual Python code here, and I'm doing not a 0 to 1 scale at the distance since I measured actual millimeters instead of, grid blocks or something like that when I was doing the drawing here and measuring of the rays. So if I say that the first one is 28 millimeters away, then that's saying a wall height of 5.4. And I think this is going to work out okay. So we're going to go with that. The first one's a 28 and the wall height is 5. So 1, 2, 3, 4, 5. Now I'm going to have to do some rounding, right? But I'm going to draw pixels here and here for the first wall segment. And the second wall segment is 25, or the second ray cast, and that's 5.76. So that's basically the same thing again. If I'm drawing exactly on these pixel boundaries, then it's going to not be very pretty because I'm doing a super low resolution version of this, but that's just where we are. 6.26. So I'm gonna kind of round up to this one. So now I am on chunk 3. $6.5. And this is my horizon line, keeping in mind this is my horizon. And these lines just shouldn't exist. But I think we will have something interesting in a moment here. So I've got 20 and 20 for the next two. And then 19 for the next one. 7.5, so I'm going to round that up to the next thing. Okay, so that got me to this ray, which has me to the very corner of this wall. Now, the next ray that I was able to cast has a length of 71. And that is going to be too high. So I'm just going to draw it right here. And then 72 and 72 again. That gets us these 1, 2, 3 that are on that back wall. Then the next one is 57. I really hope this all edits into something that makes slightly more sense. And that is now this line segment. And I'm going to round this up to this, which I know is not quite fair, but then 54. And that's approximately the same place again. And the next one is 41. 3.5. All right, 35. So what I have here is just some heights, basically, right? Things that I know that I can draw. And I just did 35, and I'm going to do 31. That's almost to 5. I'm cheating a little bit on my scale. I know I am. So that was 29, and then 31 again gets me to here. And then a distance of 33. And I was hoping that this would give enough of a scale to actually show why the fisheye has been created, but I don't think that we will. Well, we'll maybe kind of start to get there. $35 was the one that I drew. That one was 35. So to match the previous 35, I'm going to do that. And then 37 will be approximately the same place again. All right, although I could have pulled that in. Actually, yeah, I should have. I'm going to do that one down here. Okay, so those are the heights, and I've drawn them half above and half below the horizon. And I turn off my calculator. And now what I did for the sake of actually making it visible what these walls were, I didn't just fill in everything. What I did in the sake of this, you know, it's a thing that I'm playing with, was to draw a vertical line every time I encountered a corner or an intersection between two wall segments. So that would say that I need to draw a vertical line here. And with any luck, we can start to see that I now have this section drawn up to the corner. And now these are the things that are far in the background. And then the next wall change that I made was here. So I did 1, 2, 3 on this back wall, 1, 2, 3, and then a fourth one starts to come up the edge. And then I've got a new wall edge here that was created. And then it's actually another new wall here. And so it's going to be really difficult to actually see that. I'm going to come in from the other side. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So then there's another wall vertical line here to indicate the corner. So you can kind of see if you squint your eye that we've got this shape where there's a corner right in front of us that leads off into the distance. There's a hallway off in the back, a wall in the back edge, and a corner that's much closer to us, and we're right on the edge of it. Yes, the vertical lines that I'm drawing are just based on knowing whether or not I changed which line segment I'm currently drawing. And for the person who just asked if that was meant to be a console ray tracing engine, it absolutely could be. I've gone very, very simple, but the original goal was to get it working on this black and white calculator, which I did, but it is far too slow. Wow. Okay. So we did that. That was ridiculous. And that took quite a bit longer than I expected it to. But like I said, my plan is to edit this into actual episodes for C++ weekly things. So that was the general theory. So let's go back to our desktop. That was supposed to be theory and movement was the plan there. I'm going to resize these elements on my stream a little bit. Okay. So we started with the introduction, we got the theory. Now the movement part of it is not terribly complicated. It just takes a tiny bit of trigonometry. So if we go back to this and we think about our eyeball looking in some direction, what we have is we're actually looking in this direction, and then this is our field of view, whatever angle we happen to choose. Now, for the sake of actually drawing out my rays here, what I have, generally speaking, is a 45-degree viewing angle, although that's not actually true in the current example that I have because I've gone ultra widescreen for my display, so I need a wider viewing angle, otherwise everything looked really, really wonky. But if I wanted to say that I'm going to draw 3 pixels on this, then I'm going to, if it's a 3-pixel wide display, then I need to draw this ray going out, and then I need to draw, well, if I was going to do 3, then I'd do the leftmost one and the rightmost one. If I was going to do an even number, then I kind of need to divide it, because most displays are even pixel widths. So I'm doing something like the 2 that are over here and the 2 that are over here evenly divided. Audio's fine. Okay, good. Yeah, I'm only doing mono capture, so that would be weird. Okay, now I'm moving in this direction, which means I have my angle. So I'm talking about the current direction. And if you look at your direction just based on like a regular Cartesian kind of plot or whatever, and I'm over here and I'm at whatever, how many degrees. I'm writing degrees here, but really I'm not doing degrees. Everything on a computer, sine, cosine, whatever built in is radians. So it's a full circle. A full circle is 2 pi radians. And, well, half the circle is pi. So whatever. My viewing angle is pi over 2 to get 45 degrees, but that's really irrelevant. Anyhow, I have the direction, and if I want to move from this point to this point, then I just need to use sine to determine which way along the sine to determine the y, and cosine to determine the x, how far I need to move. So if I go back to my code here, then I've got this code. Let's see. I have, if your up arrow is pressed or down arrow is pressed, then try to move however many units of movement. So try move takes the current location and creates a new point that is the distance that you want to move times the negative sign of the direction. You know what? I probably have my negatives and positives reversed here. It should be forward movement and not negatives on these things. Maybe I should fix that at some point in the future. But anyhow, it's the distance times the sign gets me the x. Crap, I did have it backward. Shoot. That should be sine. And then cosine for the y. And then the cosine of the direction. And that just tells me what my new segment should be, because the angle with sine and cosine tells me what component is x and y of the direction that I'm moving. Oof, goodness gracious. Okay, so I know how far I want to move. Now, when I go to move, I need to see if that movement is going to run into something. So let's just say I am right here and I am currently facing this direction. Oh, I am writing on a screen that you cannot see. Let's go back to that. I am currently right here. I want to move forward. I have to see if the amount of distance that I'm going to move is going to intersect a line segment. Because if it is, I can't move there, then I would be busting through a wall. And I am doing perfect collision detection here. So as far as I know, it's absolutely impossible to just like run as fast as you possibly want to and bust through one of my walls, because I take the proposed move and generate a new line segment from my current location to my new location, and then check to see if this new line segment that I've just created would intersect with any of the walls in the entire engine. And if it would, then I'm not going to allow that movement. Otherwise, I do allow the movement by simply updating the location. Then on the next screen draw, I'm going to get a new perspective on the situation. I don't have to do any such check for a rotation, because a rotation never moves you. Your point of origin is always staying in exactly the same place. So I think that covers what I wanted to talk about for the actual theory and movement here. Now, what you may have noticed is I'm not doing any of the old school tricks at all. If you want to see the old school tricks, like how you would actually do something like this with, performance on like a, 386 or something, then I would suggest that you check out an entirely different video. And now is the appropriate time for me to mention this. It's Matt's talk on raycasting. No, so look, I search for Matt Godbolt, you give me some other random person. Why are you giving me another random person? Why? No, not Matt's path tracing video in 3 ways. What is happening here? Let's just go straight to Matt's YouTube, and we will look at all of Matt's most popular videos. And we will see Wolfenstein's 3D map renderer. No, I do not need YouTube Red. This video has 243,000 views. So check out Matt's video, which actually talks about how things like this were done back then. Today, I am doing, well, not the old school way of doing things. My way is just a crap ton of line segments. And in fact, when the application actually starts up, you can see that I have 524 segments that have been defined by the user with this little DSL for defining your map that I have written inside of my game. So this is not a grid-based, block-based thing. Lines can be any arbitrary length, any arbitrary angle, any distance. They can be anything, and I will attempt to draw them correctly. Oh, that's weird. I just lost like 40 viewers all at once. So I'm guessing that that's not actually my fault. I'm not sure what it's doing right now. Okay, so that is the simplest notion. I have coming back to here, I have actually done some true 3D stuff right before doing this, by the way. And that's not what I'm doing right now. Right now, I'm having fun with the Raycasting engine. So hopefully this makes sense again. You can kind of very roughly see the 3D layout of this, and I could totally do this in FTX UI and it would absolutely work. I just realized that, and now I feel like I absolutely have to. So we're going to make a quick note that we're going to allow FTX UI as a rendering engine. If you don't know what that is, you should go look it up because that would be incredibly awesome. Yes, FTX UI, all the things. I agree. Okay, that was theory and movement. Now let's talk about the fisheye aspect. Now, it's difficult to see here, but what we got is like a curve on this wall, and a curve here, and a curve here, and a curve here, as these things are kind of going away from the eyeball. And again, now, I've been doing all of this without looking up how people would normally do this kind of thing. I'm just winging it here because I wanted to do it for my own education, and I was having a lot of fun doing this. So now we're going to get to the actual new code. And the problem is, as you can see, I drew all of these rays straight out from a single eye point. And so naturally, the bigger my field of view, the more of a fisheye effect I'm going to get, because each of these points is going to get further and further away from the eye. Now, as I see it, the ideal would be to not necessarily think of it as one point. Like, I still need that one point for the calculation of what's viewable from this point. But yes, time for distance to camera plane. Exactly. Thank you. That's where I was just getting ready to go with this. Instead, now I want to do distance like this. My actual distance measurement will be like this, but what's viewable is going to be from the eye point. And I think that's the correct way to do it. But again, I've never done this before. I'm just having fun. But since we were just looking at the sine and cosine nonsense over here, if I've got my camera, it's pointed this way, whatever angle this way is, then I know that what I care about for any given ray is this distance right here. You know what? I'm going to go get different colored pens. Oh, lag happened. Sorry. Well, I'm going to get some different colored pens. I'll be right back. Look, I like multiple colored pens here. I've got blue, red, green that we can play with. I actually do keep most of my notes on written paper. Personally, for me, I find that it just makes the entire experience of taking notes in education just so much better. Okay, so I've got some angle. How do I want to do this? I had this totally at 3 o'clock this morning when I couldn't sleep. I knew exactly what I was going to do. So, now I don't care about the actual raycast. No, I won't have the way to look through a corner because like I said, all of the actual rays cast will still be coming from one point, but then I want to count the distance being just this distance. So I need the intersection, whatever this XY intersection is, which I already have. And so I'm going to write that over here because this will make sure I'm not accidentally thinking about 90 degrees for everything. And if this is my eyeball angle, no, I don't want to move the eyeball in front of the camera plane. I want the eyeball to stay where it is. The focus isn't going very well here, is it? Sorry. I need to know what this angle is. And once I know that angle and that distance, oh, so I already know that distance. I already calculated that distance when I calculated the XY intersection. You're all just listening to me think. So I've got the current angle, whatever this is, and then I've got the difference. So the original angle matters, and then the how far away I currently am from the eye matters. So if I need to worry about this 90 degrees, that represents this entire arc, but I care about so that's my current angle, minus the distance from that angle. Is that right? Oh my goodness. Let's just play with this. This is the best way to do this stuff.
Good evening, folks. At a hearty...
Okay. Now that's filtering the line segments. I'm going to get rid of this window so we can see what we're doing. I have to move some of my lighting. Good evening, if you're heading out. So this distance right here is calculated from this intersection, and the rays, what is the ray? C dot rays. So I yield the current, just the current direction. Okay, that works. The location plus the current angle, okay. That's weird. My navigation isn't working like I expect it to. Okay. You have the hypotenuse and the base to get the side. I have the hypotenuse and the base to get the side. But I don't know the length of the base. I still need to get that. Project ray hit point into camera plane and get distance between projected point and hit point. Is hit point XY known? Yes, the hit point XY is known, in fact. It should be. So if I intersect a ray, then I get these segments and I return the distance from the eye, the point of intersection, and the segment that was intersected. Why do I navigate forward and navigate backward keyboard shortcuts? Not working right now. I'm also getting far too many notifications to my phone. Yeah, good luck. I just tried something completely random, and this is part of the fun of this stuff, is seeing what it looks like. Whoa, now I have inverse, I have inverse, that is so trippy. No, I'm not trying to raycast from the camera plane. I'm just trying to calculate distance from the camera plane. And I am now at this point just hacking away at it because I know that I don't know what I'm doing. And I really should probably just look this up or something. But I'm also counting on one of you to... Whoa, that's definitely not right as well. Did I get sine and cosine backward again? Is that the problem? Oh, it's so awesome when you get the rendering wrong. That makes it all the more worth it. What is happening? I've now tried all four combinations that are possible here for what I thought would be correct. And it is clearly not correct. The angle from the looking direction to the point is the ray angle. The ray forms a triangle. Yes. Where the looking direction is 90 degrees from the camera plane. That means that the angle from the hit point back to the camera plane is 90 minus the difference between the looking direction and the camera ray. That's 90 minus the looking direction, the difference between the looking direction and the camera ray. Yeah, that's what I tried to do. On line 376, you're comparing addresses, not values. Yeah, that's fine. It's that is actually correct for what I wanted to do here. The angle from the hit point back to the camera plane is 90 minus the difference, which is pi over 2 is 90 degrees, right? Yes. Because pi is 180, yes. Ah, that's what I did. R dot angle is delta from the looking direction, or is it a compass? It is a compass direction. R dot angle is a compass direction, not the delta from the looking direction. Yeah, so that's just the ray cast, and then I have to. So if I'm looking at 0 degrees straight up, and yeah, let's just draw this out. So if I'm looking this way and I have a ray at, let's say, 1, and I'm looking at 0, then and this is my, yeah, the distance here. So I need to take the camera angle, no, the ray direction minus the camera angle. Oh, sorry, I just realized you can't see what I'm writing down here. I'm gonna go back to this. So if I want to do this, I've got, let's just say, I'm doing the simple case. So if I've got an angle of 1, then I need to say this then becomes, say, 90 minus 1. So that's the camera angle. That's the ray angle, ray minus camera. And then 90 minus that. And then I want the cosine of that, right? No, the point is that we're reinventing it ourselves. We don't want to look at the Wolfenstein 3D repo. That's no fun. So ray angle minus camera angle, 90 degrees minus that, and the cosine of that times its distance should be right now, right? Oh, that is so not right. That is so not right. What is happening? Let's make sure we didn't break something else ridiculous. No, this works exactly like it should. Let's go back to the paper. Now I'm gonna take a new sheet of paper at this rate. I'm using twice as many sheets as I normally would because I have half of my notebook underneath my laptop. So let's say my camera angle is at TDD approach would do the job here. Oh, it probably would. Oh. Yeah, no, wait a second. Yeah, TDD approach would probably make an awful lot of sense. Yes, you're 100% correct. The video is unstable. I'm sorry. It says I have an excellent connection over here. If anyone else can tell me if you've got a bad angle, a bad thing happening here, then let me know. Is it possible? Wait a second.
Good evening.
Yes, I'm attempting to get the perpendicular distance, but I don't know the math. That is the problem. So how do I do, let's see, you said sine of angle. The angles are in radians. Everything's in radians. Hence the 2 pi. Isn't it fun when you have no idea what you're doing? SOHCAHTOA, sine over, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. That's what is the SOHCAHTOA. So no need for sine tomfoolery. Okay, transcendent function, sure. I still need someone to tell me where my math is going wrong, though. I was going to try to draw it out here to understand the problem. I find it fascinating how many people are sticking with me as well. So if my eyeball angle is whatever this is, 15 degrees, and my current ray is at, say, 20 degrees, then I need, and this is my intersection point here, and I need to know this distance. Then I need to know sine is opposite over hypotenuse. So that is sine that I'm looking for, right? That's what we just said. Yes. Sine is opposite over hypotenuse. And I need to know am I overcomplicating this? This 90 degrees I need to know what that angle is. So if I take 20 minus 15, yeah, that's 5 degrees. Then this angle should be 85, so that's 90 minus, that's what I've already done. And then the sine of that angle of 90 minus the angle of the camera, no, the angle of the ray minus the, oh, wait a minute. I really should write tests. Everyone is absolutely correct on that point. Oh, goodness gracious. All right. Okay, this is still wildly wrong. But in a different way, because I was using the wrong thing here. So direction, not viewing angle. So that's better. I don't need this intersection lookup. Wait, no, I don't. I need the distance from the eye. That I already have. Right? Yes. Hmm. Yeah, I'm reading your comments. Direct camera direction and camera plane must be rotated. For some reason, I was thinking that that wouldn't necessarily be the case, but I clearly am misunderstanding the math here. And I see your comment about offsetting the position dx dy while hit x position. So you're taking into account, but I already have the distance saved from where I currently am, which is why I thought I would be able to just calculate the length of the other leg of the triangle. If you model the forward as a vector, then you can just do the dot product between the hit and the right vector. You say, just do the dot product. I say, it's been nearly 30 years since I've taken a linear algebra class. So let's go ahead and look up dot product. The scalar product, let's see. In mathematics, the dot product is an algebraic operation that takes two equal length sequences of numbers, usually coordinate vectors, and returns a single number. Okay. Dot product is the sum of the products of the corresponding entries of the two sequences of numbers. Okay. What does that tell me? The dot product may be defined algebraically or geometrically. Geometric definition is based on the notions of angle and distance of vectors. Okay. Points in space are defined in terms of Cartesian coordinates. Euclidean space itself is commonly defined. Okay, sure. This hasn't told me anything yet. Wiki pages are scary and bad for math stuff. If I'm not wrong, Euclidean distance would only give Feshbach effect. Look at some public math lab and look what they do in their Vector 3D classes. No, you guys you're all missing the point. I don't want to just look at how someone else does it. We're having fun. All right. I'm going to do it this way. Distance from a point to a line. Case of a line in the plane given by the equation, I can get a line equation. Distance from the line to a point is Dot product is the step you do before the square root to get the length of a vector. Okay, that makes some sense. Discard the Euclidean distance you have saved. Instead, use the point in the world where the wall hit. Find distance of that point to the line. Yes. Camera direction plus 90 degrees. Okay, that is approximately what we're aiming for here. Ooh, neat. If a line passes through a point, all right. So I've got the, all right. So the camera, I don't remember. It's been a little while since I wrote this code, what all functions I gave it. Thought I had a 2 line, I guess not. Okay. So I've got, no, that one takes the slope. I want the ray, that is the camera. Yes, okay. Camera's current location and its current direction. All right. That's the camera plane. And then the intersection is that point. And we don't care about that. We don't care about this angle, but we're going to need the distance from the plane in a minute. Oh no, that went very terribly wrong for a second here. Distance is the cosine of the point in an angle, okay. All right. Oh no, I don't actually want the 2 line here. I just want that ray. All right. So that angle of the current camera plane times of some point. Okay, oh, I need the point, okay, of the, right. This is not redrawing correctly. Point, that's the camera point minus the point that I care about. What? We're gonna have to worry about, oh no, there it goes. Okay. Nope, minus. Yeah. I really do need to add tests for these things. I'm gonna absolutely agree here. Oh no, something is right back where I was. What is happening? Camera plane of angle. The camera plane is the camera direction plus 90 degrees. That's pi over 2. Right. And the intersection point. I'm just going to double check that I'm doing what I think I'm doing here. Yeah, it's definitely the Oh, come on. Passes through some point px, py with an angle theta. Oh, absolute value. Nope, that didn't help. Why didn't it help? Now, I'm not getting any feedback from you all here. I'm doing that right. Cosine of the angle times point of origin of the line minus the point that I want the distance to minus the sine of all of that. Um, the question, are you sure I don't have infinite distances in my math map a closed environment? I have very, very far away distances. I do allow that, but then I do actually have bounding boxes to prevent me from trying to intersect with any of those. So I shouldn't ever get to this point. I shouldn't ever get here if it's something that's behind me, basically. Keep ending up with the exact same problem. I mean, it really looks like it's doing the same thing over and over again. It's very weird. camera plane is the location of the camera. It's the direction of the camera plus f.pi over 2. It's a 90-degree offset. Oh, wait, let me try something. I just want to see if my math is being thrown off by the fact that I've got a very weird whoa. Jason is rotating the intersection point. Am I? I am. Am I? No. I'm not rotating the intersection point. Am I? No, I shouldn't be. The intersection point should be an actual map coordinates. And the camera this is ridiculous. I mean, to Colby's point, I'm just following the instructions on the silly Wikipedia page. The line passes through a point P, X, and Y with an angle of theta, then the distance of some point X sub 0, Y sub 0 to the line is to the distance. It's the absolute value of the cosine of the angle times the camera origin. Yeah. Am I sure that C direction is an angle? Yeah, it should be. But let's just go ahead and look at that. Yes, C direction is definitely an angle. So I take the current angle and I slice it up into the number of angles that I want to render. And then I have a generator here that generates a new ray based on the location, starting location of the camera. And the offset of the current angle as it's rotating around. Looks like calculation of raw height is wrong. What? Wall height divided over length. No, that's correct. Wall height, the wall height gets smaller as the distance gets further away. It's inverse proportional. That is correct. So for those of you who are just now joining perhaps or are not clear what's happening here, if I take this, make my distance from plane just the distance from the point in the eye, so that's complicated. But if I do it like that, then everything works correctly and I just have this fisheye lens perspective that I'm trying to deal with. And I rotate much faster when I'm looking away because I haven't put any proper timing into this yet. So that is actually, correct for some definition of correct. I'm just trying to figure out how to get the distance from the plane that represents the current camera angle direction is definitely an angle. Yeah, I just did that. Just for the sake of trying to prove that it was working correctly previously. Hey, C++ is a C++ Python is my prototyping language here, y'all. Goodness gracious. People give me a hard time for using a different language every now and then. So like I said at the beginning of this, actually, if you were to go back to the beginning, this is kind of C++ cross-training. We're playing with other things than we normally would so that we expand our horizons and learn new things. I am recording all of the things. It will be live, available for playback on the channel, I promise. I'm just curious what happens if I do that. That has to be wrong. That is so trippy. Oh, I love that. All right. I don't understand what is happening and why it keeps doing the same thing over and over again. Can I please separate camera plane into camera angle and camera location? Sure. Yes, that's fair. And at some point yeah, okay, fine. Maybe we'll start creating some some test of all of this. I thought that this was going to be easy. uh, oh, well, that's possible that I am actually rotating. So you're saying if I'm at a negative angle, use the 90-degree cosine sine swap. Corrected distance. And I was, yeah, okay. Corrected distance is the cosine between your viewing angle and your current ray angle. Yeah, I was trying to not correct the distance. I was trying to properly calculate the distance, which, I apparently we're not getting there at the moment. subtracting 90 or adding 90 should be the same deal, and we get the exact same result here. Now, if I'm actually rotating from a different angle, like Ziliphian, I have no idea how to pronounce your name, says, then I theoretically would be looking to swap the sine and cosine here, I believe. No, that didn't do anything useful. Yeah, I tried minus math.pi divided by 2, and I got the exact same result. It shouldn't make any difference that way. And no, I don't think I'm doing any weird tricks for... Huh, no. Ah, stop that. No. My logic for if I... There is... You can't hit a wall to answer the question of that commenter. I'm doing perfect wall intersection detection by using the actual angles, using all the actual wall segments with the presumed movement location. What is happening? This is driving me insane. What in the world? All right, fine. We're going to do the distance from I, and then distance I'm going to try the corrected distance. Yeah, this is actually very similar to what I had already tried before. Yeah, I mean, I was planning to do a commit as soon as I actually accomplished something here. And what I'm trying to do is get rid of the fisheye by doing a correct planar distance calculation in my raycasting engine. And I am simply failing over and over again to actually accomplish that, which is incredibly annoying. So we're trying yet another method of calculating the distance from the plane, which this should be incredibly similar to what I had before. Yeah, that did not change a thing. I just thought to realize, wait a minute, what's the heck's the possibility that I actually have like a different like the distance is being used somewhere down here? But no, I don't have that problem. Yeah, the repo's right there. It's in the URL. I mean, like it's right there on the screen right there. See that? github.com/lessthedkiss/raycasting. I am not doing anything different from what you all like. Nothing's been committed since then. Now, keeping in mind that the angle might be on either side of the camera angle, right? So if I'm just going to swap back over to my camera real quick, if I've got my camera pointing this way, then the ray could be over here or it could be over here. And maybe that's the problem. I think it might be. Installing PyCharm. It works equally well with whatever, VS Code, whatever you want to use. Yeah, so the angle could be on either side. I don't think method camera.raise yields incorrect rays. Everything else is working correctly. I have the initial point and then I do raise evenly divided. Am I sure that ray dot angle and c dot direction are the same thing? They are generated from each other. So if I have a camera and I have this rays generator that takes whatever the viewing angle is, divides that by how many rays I want to generate, takes the current direction, yeah, right, and then slices it up. And well, figures out what the slice size is and what the starting angle is, and then iterates. Yes, to our 7341 hacker, we've been trying lots of different things for doing distance from plane to distance to point, and none of it is doing what we expect it to do. And I am very confused. So I don't see what you're trying to say. Nick, it could be an int to float thing. No, this is Python, not an int to float thing. Integers, I don't believe they exist. No, I'm just kidding. It shouldn't be an int to float issue. All right, fine. How do we make a test in Python? I'm still learning this language. In all seriousness, let's start creating some tests. Python unit test. Okay. Sure. My test case. Test something. What does this new star mean? What is happening right now? Hey, Leslie. Sorry you can't hang around. Hope you have a good night. No, the ray implementation is not defining the angle in camera space. It just starts with the angle from camera space and then moves around. When distance to plane is 0, the height will be infinite. Yes, that is absolutely true. When the distance to the plane is 0, the height will in fact be infinite. And I think that that is not incorrect because, well, first of all, I actually have an if to make sure that if you actually are 0, that you don't actually jump into that calculation. But in the case that your eyeball is 1 millimeter away from a wall, it's going to appear infinite to you. So that is actually, I think, correct, and doesn't seem to be the problem to me. All right. Sure. Okay. All right, I see. This thing derives from unit test, test case, fine. All right. But what is this? What is that? Assert true. Okay, that's gonna look up frustum. What's a frustum? Okay. Yeah, with I don't think that this is helpful because we are doing a very simple 2D raycasting engine, but I could be wrong. Yeah, and I am clipping the wall height for those of you who are currently looking through the source code right now. Yes, see? The frustrum is a 2D line. It's camera plane. It's raycasting. So it should be, that's my understanding here as well. So I need to import raycasting. All right. This is why I do this. I don't know why I do this. I think I do this because I'm practicing for upcoming training that I have. Um, Look, so for those of you who keep saying if you get your view frustum correct, it'll correct your FOV problems. This is not how you explain something to someone who doesn't know what you're talking about. You're just using a bunch of geometric, 3D geometric terms that don't mean anything at all to me. Now, what we've been attempting to do is to just calculate the distance from a point right. I just realized the problem. Wait a minute. Yeah. This is dumb. Every single one of these have actually been working correctly. Okay. Good evening, Vienna. Here. This is dumb. I'm gonna swap back to this. No. We'll stay over here. All right. Let's draw this out. We've been doing it right and wrong the whole time. All right, so say we've got the walls that are similar to the ones that we drew by hand. And it looks something like this. And yeah, sorry for misunderstanding or not understanding all the things that all the people were saying. But let's put my camera back here. And I'm going to, draw our viewing angle. And I'm sure for all of you who actually understand 3D geometry that this all makes sense to you already. Excuse me. Now I need to go like this. Anyhow, let's just say that my main viewing angle is in the near and far planes of the camera. That makes sense. Thank you. This is my viewing angle. This is my 90-degree line that we've been trying to draw. And this will be great for when I edit this video in the future. And now we say that we had an intersection right here. And before, the distance was, whatever, 37. No, actually in millimeters, that's more like 15 or something. But we were drawing this line and saying, now show me the distance here. And I see now the point of the person who is saying that the distance from the camera is going to make it infinitely big. And I'm like, yes, that's true. That's the whole point. Because if your eyeball's right up against the thing, then it's infinitely tall. But all we've done actually is exacerbate the fisheye by saying, show me the distance from here to here now, because that distance is getting smaller and smaller the further we get this way on our camera plane. So that's not helpful. I don't know why I've been thinking about this for like 3 weeks, and this whole time I thought that this would solve the fisheye problem, but really it just does make it worse. Every single one of our tests have been correct. We just weren't calculating what we thought we were calculating. So now to those of you who are saying I just need to calculate my view frustum, what I need you to do is show me a diagram of what I'm actually looking for here, because I do want to know the distance. Yeah, projection and ray tracing are two opposite views of handling perspective. Okay, so we are trying to we were taking something that appeared to be curving away from us because it was getting further and further from our eyeball, and now are making it appear to be getting closer to us. Yeah, and I'm not trying really to reinvent anything here. I just want to understand the math for how this works. Need to step along the ray of the wall, per se, to get this into the camera, which is what I've been doing. Like, I already know this distance. The pixels on the frustum. So I want to know how, what you're saying to me, if I'm understanding this correctly, is mapping my viewport of some sort, not this entire line. But the distance to the camera plane, like I said, it's getting closer and closer and closer. The problem is that my camera plane is infinitely long. That's the problem. So right? I think that's part of the problem. So the angle, though, hopefully this edits into something reasonable for the channel later. So the distance to the spot on the frustum versus the distance to the spot on the plane versus the distance to the eye view. I'm warping it by assuming they're all the same. I'm not assuming they're the same. I'm just doing bad math, really. Wow, my camera is really freaking out with its focal length here. Calm down, calm down. What you need is the distance projected along your view, the direction angle, which is also the perpendicular distance. The first distance you get is distance between 2 points, which gives you the fish. Yes, that's what I have. That's what I knew that I was doing. That's what we started by drawing a couple of hours ago. So if I were doing something like this, projecting onto a local cylinder, then or no, an actual eyeball is rounded on the back like that. Yes, that's what I'm doing right now. I only care about the camera plane, not the line. So, Zilfian. Uh, but I mean, it does make sense that by doing the distance from this perpendicular line, like we've been doing, is why I'm getting exaggerated wall height on the edges now. Okay, if I were to care about the bounded plane, what would my bounds be? And how would I scale such a thing? Need to look at it sideways. Okay, I'm going to refresh my tea. You all can continue to discuss this for a minute. You have the source code in front of you. I need a break. I'll be right back.
Good evening, folks, and a hearty welcome to our drive-in theater. We have a wonderful evening's entertainment lined up for you, one that will provide several hours of pleasurable relaxation and diversion for you and your family. Did you fail to dress up for tonight's show? No tie, an old shirt and slacks, a house dress? Well, don't give it a thought. We're glad you came as you are. We just want you to enjoy yourselves. Don't forget to visit our refreshment center during the intermission or any time. You love the tasty array of snacks we have to offer. So will the youngsters. Everything is quality and so good. We hope you'll make this a weekly visit. Bring the family. Bring your friends. There are always wonderful new pictures to see, delightful snacks to nibble, a gay, pleasant evening for all. Oh, a word of caution. Don't drive over 10 miles an hour in the theater area for your safety's sake. And Mom or Pop, go with the kids when they leave the car. We hope you have a wonderful time. Come back soon.
It's 4 minutes till showtime.
Hey, fellas, don't fight over that hot dog. There's plenty for everyone. Big, plump, and juicy, wrapped in an oven-fresh bun. Add mustard, relish, ketchup, and go to work. Yes, the hot dogs at our refreshment center are the best you'll find anywhere. Everybody agrees on that.
It's 2 minutes till showtime.
Your attention, please. All new Hotshot electric in-car heaters have been installed for your comfort and convenience. Just insert heater through car window and turn on the switch. When leaving, please turn switch off and replace on speaker post. Warning, high voltage. For your own safety, do not attempt to repair or remove wires. Do not attempt to open heater unit. If you need assistance, please notify the theater box office or concession manager.
Top quality hamburgers, the most popular snack in the country. We serve them plain or garnished to your taste.
And now, on with the show.
You've seen the show. It was quite a treat. But now you'd like something to eat, so right this way to the concession stand serving Castleberry's, the best in the land. Yes, sir. Castleberry's is real southern barbecue. Choice cuts of meat slowly cooked over open pits of smoldering oak coals for honest-to-goodness barbecue flavor. You'll also find hot coffee, cold soft drinks, and delicious ice cream in our snack bar to go with your Castleberry sandwich. Just look at that generous helping of rich, juicy barbecue. Yum, yum. For a real taste thrill, Castleberry's barbecue will fill the...
Golden, pure creamery butter, rich, flavorful, satisfying. That's what it takes for the finest buttered popcorn, and that's what we use. See for yourself why there's no Showtime treat to equal the crisp, delicious flavor of hot popcorn that's bathed in real melted butter. It's at the concession stand now.
You don't have to just dream about Dairy Queen. Your favorite Dairy Queen treat is a refreshing reality at your nearest Dairy Queen store.
Hey! They're ready, folks. Visit our refreshment stand right away for delicious orange crush and all kinds of good things to eat.
Let's play Dutch treat. Da 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 da. Oh, you're it. No, I'm not. Come on. I'm it. 1, that's 2, that's 3, that's treat. 4, that's 5, that's 6, that's treat. 7, that's 8, that's 9, that's treat. That's treat chocolate drink. Oh, that's treat chocolate drink, please. That's treat drink so good. I want some. Me too.
Needs to draw his rays from the individual pixels on the front face of the box. Wall height equals the tangent of half of the field of view distance to wall. I'm going to just kind of hack around here for a minute and see if I understand what you all have been trying to communicate with me. So I'm just going to be trying some stuff and see what it does. Okay, so Colby, you are, no. Yes. So you're suggesting that I move the actual camera point down the ray, down the array, down the ray. That's what you're suggesting. I'm moving the point of origin away from the ray, basically. And therefore, but won't that change what is viewable? Yeah, making a frustum in the math, right? I think I understand what you're suggesting. Okay, so I'm just going to go ahead and try that real quick. We're going to base this off of distance from, yeah, we're going to call it distance from I still. I'm going to comment this out, and I'm going to see if I understand what you're doing. So you're saying here at the ray location, I'm adding a new point to it that is the cosine of the direction, the sine of the direction, so that I'm actually, yeah, I'm actually moving the viewpoint to further down, right? Am I understanding that? Yeah, so there's still a slight curve to it, but it has been modified a little bit. Now, when I'm actually like up in the business of this, then I still get the same kind of problem. All right, so I want to I undid that. I want to try something else. I don't know. Let's see. Yeah. Okay. Um, I'm using PyCharm. No, I'm not going to do that. Okay. I'm just trying something here. I don't know what I just calculated. I should probably look that up. On column 0, the current width of the screen is 640. Yeah. All right. No, don't restart. Don't run. Where's like step? Step. Huh? Oh, I hadn't even gotten there yet. Okie dokie. Okay, right. So Oh, I clearly did that wrong. Sorry, I'm playing here. It's still a rather significant fisheye effect, though. It's still not quite doing what I want it to do. Is this distance from center actually correct? This is fascinating. Actually, that is fascinating. No. The distribution of the ray should be equal distance along the view plane rather than the equal angle spacings. Right. I understand that. You sort the rays by closest to the camera. After that, you compute distances. Correct. However, what I did was for every angle, cast 2 rays. One steps until a horizontal hit and the other until a vertical hit. Equal angle spacings would look bunched up close to the center and wider. Yeah, I hear you. I That's an interesting point. Huh. Now I have no idea what I'm doing. Yeah, okay. Okay. So your point, okay, I'm starting to understand your point there. Right. And I'm afraid that we're not going to get this done. I've only got 45 minutes. And before I need to stop here. So I think I understand everyone's points about where the it is kind of fun though. But it's interesting that it basically, no matter what I do, I keep getting the same kind of weird fisheye thing, which I find just beyond fascinating. Actually, I'm going to try something here. No, that's not going to work. Yeah, that's not going to work. Okay. All right, I'm looking back at the I've corrected the ray distribution on my local copy, still got fisheye with the plane distance. It's really hard to get that right. I think there are a number of effects that we're all adding to that are all adding to the fisheye. All right. So I was just trying to say, okay, the distance out that I am, I need to the walls get further away. I need to make them bigger if I am away from the center viewpoint. So the bigification that I need to add to that is proportional to how far I am from the center. So if I just want to, and I just want to make sure I'm understanding this, I'm not saying that this is the correct solution just for the record. So if I just want to add some constant that is, say, I don't know, something. I'm going to say whatever the current screen height is, divided by 4 is going to get added to me dependent on the distance that I am from the center. Something like that, just some like flat compensation. And I just want to know what that does. It's like it's doing nothing. Am I executing the same program or not? What is happening right now? You know, you can really, like, you play with these things and you realize how you could do some seriously trippy mind trips on people who are trying to play your game by messing with this stuff. Yeah, that's clearly wrong. Okay. I feel like I'm starting to vaguely understand what I'm looking at. Okay. I don't think I know enough Python. This code looks quite bizarre to me. Most of it should look pretty straightforward, I feel like. The main thing that it's Python-y that I'm doing is, well, there's a couple of list comprehension things, but, well, pay no attention to the optimization code that needs to be cleaned up. Yeah. This is very disappointing and annoying. And viewership agrees. We're down to 58 viewers. But I would love to actually fix this. So I think I understood everyone's points that if you change the distribution of the rays, or if you change the starting point of the ray, then you get some sort of compensation. Now, my problem is because the way my intersection code works, if I change the starting point of the ray, then I'm not going to get the same wall intersections that I currently am getting. Yeah, Drew, we'll give you a quick update here. Really, not a whole lot has happened, except that I am attempting to I have this very simple raycasting engine written in Python that works, but it has a pretty pronounced fisheye effect going on, walleye effect, whatever going on. And it's a natural side effect of calculating the distance of all the rays from the point of origin. And we're all trying to figure out where I can do this correctly, which, by the way, I actually know this maze pretty well because I've walked through it far too many times. So that we're not having to compensate, but the math is, you know, kind of correct-ish. And we're not getting this kind of fisheye effect as the wall moves away from the viewpoint. Now, there's discussion about actually using no, the interaction stuff is 100% correct. The intersection stuff, I have actually, I mean, I don't have test on it, but that stuff I have no complaints with. It's definitely drawing all the lines how they should. So the question is, how do we calculate the distance from the eye to the wall segment in a way that actually makes sense? And we don't have a good answer for that. Now, if I had done this as a proper 3D engine, then we might have a proper 3D engine answer to this. But I'm trying to do it as a 2.5D raycasting engine, and we're trying to collectively figure out the math for it. Yes, I'm testing each ray line against each wall. Absolutely. Because, well, in the future, I want to be able to do things like have a window and have it draw correctly, which I could do right now. I just have to draw from back to forward. So that is intentionate. Why is it not raycasting? Well, I'm doing something. I'm casting rays from the eyeball to see which wall I hit, right? I'm not doing it in the stepwise fashion that something like Doom would have done, or Wolf. So how wrong did I do this then in my attempt? Okay, this technique will work fine. I get the comment here for those of you who are catching up on this later. But to go back to the camera, if I try to draw a line that is perpendicular to the camera and calculate the distance, then I get the opposite of fisheye. I get the walls get gigantic as they get close to me instead of getting smaller as they get close to me. And I need the situation to be in between those two. And I am casting one ray per wall slice. Now, if I had this as the area from which I am casting the rays, then I could get possibly the right compensation for it. But by doing that, I risk accidentally clipping into a wall or getting my view occluded, because I am really truly relying on every ray being cast from that one point out through each column slice into the wall. And all of the math and everything works out exactly like I expected it to. Yeah, so I am stepping one column at a time. You can see my cup of tea here. So if the more oblique the angle is, the more of a compensation I need, I guess. So the further out the angle from, and this is where some of you have tried like changing things so that or changing where the rays are cast from. Ray clipping, sure. Then I need to say, okay, so this is where we were playing with like the angle off from the camera. And the more off we are from the angle of the camera, then the more compensation we need. And the bigger that angle, the larger the wall segment needs to be. Okay. Sure. Oh, right, right. That's funny. That's the wrong number. That's why. What is happening? That's actually almost right. What is happening? What am I doing? The angle from the camera is 0, then I get absolutely no height compensation. Otherwise, I do get height compensation. Yeah, that last one almost looked like it wanted to be right, but it was wrong. Because it was growing by too much. Man, is he like taking drugs or something here? Huh. Okay. I think this is similar related to a suggestion that someone else had made earlier. That is truly amazing. All right. It doesn't look like we're going to get this solved today. I have a meeting that I have to get to in 30 minutes. But I want to play with this for a minute more. And I totally appreciate everyone's input here on this. And I'm super disappointed that this distance from the plane of the camera didn't work like I expected it to. Although I guess if I still cast the rays how they were being cast, but then calculate the distance based off of huh. Okay. Yes, the distance is calculated from single origin to each point. One infinitely small I, correct. That is how it is being calculated right now. It is a single point. So based on what other people have said here, like, okay, so if I still move the actual ray that is being cast, but instead just move it when I go to calculate the distance for the sake of rendering. So if I take the current camera location and I add to it some movement along the current ray, and this is what other people were showing a moment ago, then I can move the eyeball closer to the location, which will make it, yeah, let's just try that. So, and this is almost exactly what someone else had done earlier. Oh, right. Sorry. I am typing, but not showing you what I'm typing. My mistake. If you imagine a perpendicular wall in front of you, then an evenly spaced pattern should be an evenly spaced on the screen. If you look at the ray distribution, it should be with the tangent of the angle. I don't know what you said. If I look at, imagine a perpendicular wall in front of you, and then an evenly spaced pattern should be evenly spaced on the screen. Okay. Suggestion, just divide distance by the cosine of the ray view angle.
Good evening, folks, and a hearty welcome to...
Sorry. Okay. Divide distance. All right, sure, why not? I'll try that. I'm open to anything. The rays need to be evenly spaced in the imaginary frustum and have the correct angle. Right. So I get that. I get what you're saying. So I'm not spacing my rays correctly. That's part of the problem for why I'm getting the fisheye. If I were to space the rays better, but I don't understand how to space the rays better. That's part of my problem. I'm going to try this suggestion from Yuri for the fun of it. And that is distance from I equals distance from I divided by the cosine of angle from camera. That did not help. I'm going to make sure I'm back to where I thought I was. If I multiply by cosine, then it'll make the walls flat instead of divide by cosine. No, that still makes them go out from the camera. I have a horizontal field of view and a yeah, right. Okay, so the ray needs to be evenly spaced. Yeah, right. Ray increment angle is issue. Okay, right. I think it's correct left to right, but not top to bottom. All right, so Kyer. If you imagine a perpendicular wall in front of you and an evenly spaced pattern should, okay, right. So walls all have a fixed height because raycasting engine here. They have a fixed height. So if I have my viewpoint, and if I have my viewpoint and I've got a wall here, what you're saying is I need to cast Am I missing something? So the further away it gets, the more densely packed the rays need to be. These are with the tangent. Okay. So how do I actually modify the code to cast the rays differently? Not by camera view angle, but by ray angle from start angle to end angle. Oh, what? All right. I'm just going to comment out all these currently not used things. Distance from eye, fine. Okay, so when I cast the rays, sorry, where is that? I accept this argument, I do. Okay. Just construct the rays by partitioning the near plane. Yeah, that doesn't help me. You need to divide not by camera view angle, but by ray angle. From start angle to ray angle, cosine of ray angle of n. What? Angle equals the arc tangent. Wait, what? Angle step equals the field of view divided by the projection plane width. And as you, okay, so that's what I'm doing right now. That's the Viewing angle divided by count. Okay, fine, fine, fine. As you loop through each column, you do current angle plus equals the angle step. Okay, right. And initialize your current angle with view angle. Wait, what? But that's exactly what I'm doing right now. Current angle plus equals angle step. Isn't that what I'm doing? That's totally what I'm doing. Oh, sorry. I have the... Yeah. No. But I can... Right. I can modify the distance between the screen and the eyeball. Yes. I could do that. Post slicing, post intersection, which is what I started to do. But I really want to understand this, dividing up the angles differently. That part also makes sense to me, but I don't understand how you're telling me, because I'm literally doing exactly what you said. Field of view divided by the projection plane width. As you step through each column, you do current angle plus equals the angle step. Except I'm doing angle step times the current step, so that's the same thing though. And initialize the current angle with the view angle divided by 2. Yeah, and then I do this slice size divided by 2 so that I evenly divide it. You need to divide not by camera view angle, but by ray angle. From start angle to end angle, cosine of the ray angle then. I don't understand how that gets fit into my current code, Yuri. Yeah, I've been here for a few hours now. I don't know what I'm doing. Okay. So, okay. Right, I'm trying to understand the comment. Angle equals the arctangent. Okay. Your angles don't depend on camera view. They need to be statically from negative 45 to 45 degrees. Yeah, but Enzo, you're not changing the angle step size with each I really don't see how what you're suggesting is different than what I'm doing, because you're not suggesting changing the angle step size. Angle equals the arctangent of the current slice. Oh, I got 10 minutes until I have to do a meeting. All right. Okay, so my current ray is the whole point was that this is supposed to be simple and easy to understand. That was what I was going for when I started creating this. Show me a thing or two about trying to make simple, easy to understand 3D rendering software. I'm going to try one last thing. Yeah, you know what? I can still try to make something simple. That's what I have to say to you. Wait, what? Oh, all right. Okay. All right. Find array angle a different way. Otherwise, leave things the same. That's what is the conclusion here. I have to go to a meeting. And I'm going to stop streaming right now. And I will come back to this question and reread your comments, everyone. So let's see if I come back later. 3.5 hours. Catch you all later.
Good evening, folks, and a hearty welcome to our drive-in theater. We have a wonderful evening's entertainment lined up for you, one that will provide several hours of pleasurable relaxation and diversion for you and your family. Did you fail to dress up for tonight's show? No tie, an old shirt and slacks, a house dress? Well, don't give it a thought. We're glad you came as you are. We just want you to enjoy yourselves. Don't forget to visit our refreshment center during the intermission or any time. You love the tasty array of snacks we have to offer. So will the youngsters. Everything is quality and so good. We hope you'll make this a weekly visit. Bring the family. Bring your friends. There are always wonderful new pictures to see, delightful snacks to nibble, a gay, pleasant evening for all. Oh, a word of caution. Don't drive over 10 miles an hour in the theater area for your safety's sake. And Mom or Pop, go with the kids when they leave the car. We hope you have a wonderful time. Come back soon.
It's 4 minutes till showtime.
Hey, fellas, don't fight over that hot dog. There's plenty for everyone. Big, plump, and juicy, wrapped in an oven-fresh bun. Add mustard, relish, ketchup, and go to work. Yes, the hot dogs at our refreshment center are the best you'll find anywhere. Everybody agrees on that.
It's 2 minutes till showtime.
Your attention, please. All new hotshot electric in-car heaters have been installed for your comfort and convenience. Just insert heater through car window and turn on the switch. When leaving, please turn switch off and replace on speaker post. Warning, high voltage. For your own safety, do not attempt to repair or remove wires. Do not attempt to open heater unit. If you need assistance, please notify the theater box office or concession manager.
Top quality hamburgers, the most popular snack in the country. We serve them plain or garnished to your taste.
And now, on with the show.
You've seen the show. It was quite a treat. But now you'd like something to eat, so right this way to the concession stand serving Castleberry's, the best in the land. Yes, sir. Castleberry's is real southern barbecue. Choice cuts of meat slowly cooked over open pits of smoldering oak coals for honest-to-goodness barbecue flavor. You'll also find hot coffee, cold soft drinks, and delicious ice cream in our snack bar to go with your Castleberry sandwich. Just look at that generous helping of rich, juicy barbecue. Yum, yum. For a real taste thrill, Castleberry's barbecue will fill the...
Golden, pure, creamery butter, rich, flavorful, satisfying. That's what it takes for the finest buttered popcorn, and that's what we use. See for yourself why there's no showtime treat to equal the crisp, delicious flavor of hot popcorn that's bathed in real melted butter. It's at the concession stand now.
You don't have to just dream about Dairy Queen. Your favorite Dairy Queen treat is a refreshing reality at your nearest Dairy Queen store.
Hey! They're ready, folks. Visit our refreshment stand right away for delicious orange crush and all kinds of good things to eat.
Let's play Dutch treat. Da 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 da. Oh, you're it. No, I'm not. Come on.